Welcome back. In this teaching video, I'm looking at 3.6 sigma notation. 3.6 represents Chapter 3, Section 6 of the Pearson A-Level Maths Pure Maths Year 2 textbook. Let's go through the key facts of this section. Firstly, we're going to look at a very important mathematical notation. We have the following. This represents the sum of UR from the first term up until the mth term. So we can open this up and we can write the following. U1 plus U2 plus U3 plus ... plus UN. So over here we've got a series and there are n terms. So mathematically we can write this as Sn. This represents the sum of the first n terms of the series. Now, for an arithmetic series, Sn is given by a half n square bracket 2a plus n minus 1 in brackets multiplied by d close square bracket. For a geometric series, Sn is given by a open bracket 1 minus r to the power n close bracket all over 1 minus r, provided that r is not equal to 1. So we have that a is the first term, d is the common difference, r is the common ratio, n is the number of terms, and Sn is the sum of the first n terms. So these are the key facts of 3.6 sigma notation. I'll be implementing these key facts within exam style questions. Here is exam style question 1. Evaluate part A, the sum from r equal 1 to 20 of 7 minus 2r. Ladies and gents, the very first step is to open up the sum. So we're going to substitute r equal 1 into this expression to find the first term. So we've got 7 minus 2 times 1, which is 5. Plus, now we're going to substitute r equal 2 into this expression to find the second term. So we have 7 minus 2 times 2, this is 3. Plus, substitute r equal 3 to find the third term. So we've got 7 minus 2 times 3, this gives me 1. Plus, ... we're going to add up 20 terms. Now ladies and gents, we take a step back and we see if this is an arithmetic or a geometric series. So what we notice over here is that there is a common difference between consecutive terms in the series, and that common difference is minus 2. So we're subtracting minus 2 each time. Okay, so we have an arithmetic series. We are calculating the sum of the first 20 terms, so this is denoted by S20. A is equal 5, the first term. D, the common difference, is minus 2, and n is equal 20. So we can apply this formula over here to work out S20. So S20 is equal a half multiplied by 20, open square bracket, 2 lots of 5, plus, in bracket, 20 minus 1 multiplied by minus 2, close square bracket. We can put this into our calculator and this will give us S20. So if we put this into our calculator, we get minus 280. Let's move on to part B. So over here we want the sum from r equal 1 to 10 of 3 times 4 to the power r. Right, so ladies and gents, we need to first open up the sum. Let's substitute r equal 1 into this expression to find the first term. So we have 3 times 4 to the power 1, which is 12. Plus, substitute r equal 2 to find the second term. So 3 times 4 to the power 2, which is 48. Plus, substitute r equal 3 to find the third term. So we have 3 times 4 to the power 3, which is 192. Plus ... We are adding 10 terms. Okay, so now we take a step back. Is this arithmetic or geometric? Well, we notice over here that between consecutive terms in the series, there's a common ratio. We are multiplying by 4 each time. Okay? Now this series represents S10, the sum of the first 10 terms. So A, the first term, is 12, R, the common ratio, is 4, and N, the number of terms, is 10. So ladies and gents, now we can apply the Sn formula for geometric series. So if I apply the formula, I've got 12, open bracket, 1 minus 4 to the power 10, close bracket, over 1 minus 4. I can put this into my calculator. So if I put this into my calculator, I get 4194300. Right, if we look at these two series here, over here we have a linear expression, but over here what we have is an exponential expression. So we know straight away that when we open up this sum, it will be an arithmetic series, and if we open up this sum, it will be a geometric series. Let's move on to part C. Over here, we want to calculate the sum from r equal 1 to infinity of 7 in bracket minus 1 over 3 to the power r. Okay, so we're going to open up this sum. Let's substitute r equal 1 into this expression to find the first term. So if we do that, we get minus 7 over 3. Now we can substitute r equal 2 into this expression to find the second term in the series. So plus, if we substitute r equal 2, we get 7 over 9. Substitute r equal 3 into this expression to find the third term in the series. So plus, if we substitute r equal 3, we would get 7 multiplied by minus 1 over 3 in brackets to the power 3. This would be minus 7 over 27. Plus dot dot dot. We're taking the sum to infinity. Now ladies and gents, over here we have a geometric series. There's a common ratio between consecutive terms in the series. Each time we're multiplying by minus 1 over 3. So A, the first term, is minus 7 over 3. R, the common ratio, is minus 1 over 3. And the number of terms is infinity. Okay, so we're looking at S infinity. This is equal S infinity. Now S infinity for a geometric series is given by A over 1 minus R. So we can apply that formula. We have minus 7 over 3 in bracket over 1 minus, the common ratio is minus 1 over 3, minus 1 over 3 in brackets. Okay, so if we put this into our calculator, this will give us minus 7 over 4. And that there, ladies and gents, completes exam style question 1. Here is exam style question 2. Find the sum from r equal 1 to 12 of this particular expression. If I take a step back, I notice that I've got a sum of two different expressions. 2r minus 5, which is a linear expression, plus 3 to the power r, which is an exponential expression. For this type of question, I must split the sum into two different parts. So that's what I'm going to do. I've got that this is equal to the sum from r equal 1 to 12 of 2r minus 5 plus the sum from r equal 1 to 12 of 3 to the power r. So over here, I notice that I've got an arithmetic series. Because the expression inside the summation is a linear expression, and I've got a geometric series. Because the expression inside this sum is an exponential expression. So I'm going to start by evaluating this sum over here. Equal, square bracket. I can substitute r equal 1 into here, and if I do this, this will give me the first term in the series. So substituting r equal 1 gives me minus 3. Plus, substitute r equal 2 into here will give me the second term in the series. Minus 1. Plus substitute r equal 3 into here to get the third term in the series, this would be 1. Plus dot dot dot. We are adding up 12 terms. Close square bracket. So I've just taken the first 3 terms in the series. Plus, square bracket, I'm going to write down the first 3 terms in this series. If I substitute r equal 1 into here, I get 3 plus if I substitute r equal 2 into here, I get 9, plus substituting r equal 3 gives me 27, plus dot dot dot, we're taking the sum of the 12 terms. Okay, close square bracket. So over here, we've got an arithmetic series. The common difference is plus 2. And over here, we've got a geometric series. The common ratio is multiplied by 3. Okay, so for this one over here, A, the first term is minus 3. D, the common difference is 2. And N, the number of terms is 12. And for this one over here, A, the first term is 3. R, the common ratio is 3. And N, the number of terms is 12. Okay? So we can calculate this sum over here using the SN formula for an arithmetic series. So if I apply that formula, I've got a half multiplied by 12, open square bracket, 2 lots of minus 3, plus, open bracket, 12 minus 1, close bracket, multiplied by 2, close square bracket. Right? So we've got plus. For this one over here, I can evaluate this using the geometric series SN formula. So I've got A, which is 3, open bracket, 1 minus 3 to the power 12, close square bracket, all over 1 minus 3. So I can put this into my calculator. So if I put this into my calculator, I get 96, plus put this into my calculator, I get a large number, and that number is 797160. Now we can add these two numbers together. So if we add them together, we get 797256. So ladies and gents, this summation simplifies to 797256. In other words, 797,256. Here is exam style question 3. Evaluate the sum from r equal 5 to 100 of 3 multiplied by 0.5 to the power r. Notice that over here we are not taking the sum from the first term up until the 100th term. We are now taking the sum from the 5th term up until the 100th term. Now I'm going to explain this concept, so have a look here. I've got u1 plus u2 plus u3 plus u4 plus u5 plus dot 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 plus u100. I want to calculate the sum from the 5th term up until the 100th term. To calculate this sum, I can take the sum from the first term up until the 100th term. So I can write sum from r equal 1 to 100 of 3 multiplied by 0.5 to the power r, take away the sum from the first term up until the 4th term. So the sum from r equal 1 to 4 of 3 multiplied by 0.5 to the power r. Now I'm going to calculate these two sums and then subtract them. Let's start off with the first sum. So I've got the sum from r equal 1 to 100 of 3 multiplied by 0.5 to the power r equal. I'll write down the first 3 terms in the series. So if I substitute r equal 1 into this expression, I get 1.5, plus substitute r equal 2 into the expression, I get 0.75. And then finally substitute r equal 3 into this expression, I will get 0.375 plus dot dot dot. We're taking the sum of the first 100 terms. We have a geometric series. A, the first term is 1.5. R, the common ratio, is 0.5 because each time we are multiplying by 0.5. And N, the number of terms, is 100. So I can apply the SN formula for a geometric series. I've got 1.5, open bracket, 1 minus 0.5 to the power 100, close bracket, over 1 minus 0.5. Okay, so I can put this into my calculator, and if I do this, I get exactly 3. Absolutely beautiful. Okay, so I've got that this sum over here is equal 3. Take away, I now need to calculate this sum. Okay, so I've got the sum from r equal 1 to to 4 of 3 multiplied by 0.5 to the power r. I'm going to write down the first two terms in the series. So if I substitute r equal 1, I've got 1.5, plus substitute r equal 2, I've got 0.75, plus dot, dot, dot. We're looking at 4 terms here. Again, I can apply the SN formula for a geometric series. Common ratio is 0.5. So we've got the first term, we've got r, okay, and in this case n, the number of terms is 4. So I've got 1.5 open bracket 1 minus 0.5 to the power 4 close bracket all over 1 minus 0.5. I can put this into my calculator, and if I do that I get 2.8125. Okay, so take away that sum, which is 2.8125. Right, so if I put this into my calculator, my final answer is 0.1875. So that sum evaluates to 0.1875. Ladies and gents, this was an example of a summation that does not start from the first term. In this case, we started from the 5th term. So if you get a question like this in the exam, you must split the sum as a difference of 2 different sums. Here is exam style question 4. Given that the sum from r equal 1 to k of 8 plus 3r is equal to 377, part A show that this factorization is equal to 0. So I'll go through part A. I'll start by evaluating the sum on the left hand side. So that is my starting point. I've got the sum from r equal 1 to k of 8 plus 3r. I'm going to write down the first 3 terms in this series. So I've got 11 plus 14 plus 17 plus dot, dot, dot. I'm looking at k terms. Now over here we notice that there is a common difference, and that common difference is 3. We're adding 3 each time. A, the first term, is 11. D, the common difference is 3. And N is K. We're looking at K terms. So we're calculating SK, the sum of the first K terms. We are going to apply this formula over here, the sum for an arithmetic series. So I've got a half multiplied by K, open square bracket, 2 lots of 11 plus open bracket K minus 1 multiplied by 3, close square bracket, equal a half K, open bracket, 2 times 11 is 22, plus if we expand this we get 3K minus 3, close bracket. So a half K, 3K plus 19. Right, so we can set this equal to 377. So a half K, open bracket, 3K plus 19 is equal 377. Now we can multiply both sides of the equation by 2. Okay, so if I do this, I get K, open bracket, 3K plus 19 equal 377 multiplied by 2, that's 754. Expand the bracket and take the 754 to the left hand side. So I've got 3K squared plus 19K minus 754 equal 0. That there, ladies and gents, factorizes to what we have over here. So 3K plus 58 in brackets multiplied by K minus 13 in brackets equal 0 as required. Let's have a look at part B. Hence, so we have to refer back to our answer in part A. Find the value of K. So that equation is equal to this equation. So from our answer in part A, we know that 3K plus 58 in brackets multiplied by K minus 13 in brackets is equal 0. There are 2 solutions. We have that if we set this bracket equal 0, K must equal minus 58 over 3. And if we set this bracket equal 0, K is equal 13. Now that K represents a term. we can't have a fraction term. It must be a whole number. So we reject this solution and we take k equal 13. So k is equal 13. Here is exam style question 5. Show that the sum from n equal 1 to 48 of log base 5 of n plus 2 over n plus 1 in brackets is equal to 2. Looks like a beautiful question. Ladies and gents, I'm going to start from the left hand side, carry out some calculation until I arrive at the right hand side, which is 2. So left hand side, LHS equal. We've got the sum from n equal 1 to 48 of log base 5 open bracket n plus 2 over n plus 1 close bracket. I'm going to open up this sum starting off with the first term in the series. So I can substitute n equal 1 into here. I've got log base 5 of 1 plus 2, which is 3, over 1 plus 1, which is 2. Plus substitute n equal 2 to get the second term in the series. So log base 5 of 2 plus 2, which is 4, over 2 plus 1, which is 3. Substitute n equal 3 to get the third term in the series. So log base 5, 3 plus 2 is 5, over 3 plus 1, which is 4. Plus dot 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 plus log base 5. Substitute n equal 48 to get the 48th term. So 48 plus 2 is 50, over 48 plus 1, which is 49. Equal. Now we've got a sum of logarithms over here and each log has the same base. So we can simplify this using the multiplication rule for logs. We can write it as a single log. We've got log base 5 of 3 over 2 multiplied by 4 over 3 multiplied by 5 over 4 multiplied by dot 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 multiplied by 50 over 49, close bracket. We see some cancellations over here. So the 3 cancels with the 3, the 4 cancels with the 4, the 5 cancels with the intermediate 5 over here, and the intermediate 49 cancels with the 49 over here. So this simplifies to log base 5, open bracket, over here we've got a half multiplied by, over here we've got 50 over 1, which is just 50. So a half times 50, we have log base 5 of 25. Ladies and gents, this is precisely 2, which is equal to the right hand side. So we have shown that this sum over here simplifies to 2. This completes exam style question 5 and this teaching video 3.6 Sigma notation. If you found the video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.